Good evening. I'm Carol Mintzer, and welcome to the general meeting of the Santa Lucia chapter of the Sierra Club. The Sierra Club is the largest and most enduring grassroots environmental organization in the United States, has 3.8 million members and supporters in the U.S., and about 4,500 members and supporters here in San Luis Obispo County. Much of what we accomplish is thanks to the hard work of volunteers. We have one staff person and a 7-member executive committee. Our volunteers are active on conservation issues, political engagement, and taking people outdoors on hikes. And now to our main presentation for the evening. Dr. Alex Mintzer is a Professor Emeritus from Cypress College in Orange County. He taught biology for over 20 years and has conducted research on ant kin recognition and leaf-cutting ant populations in southern Arizona. He grew up in Tustin, California, graduated with a Bachelor of Science from UC Irvine. He then moved to Ann Arbor, Michigan, where he completed his doctorate from the University of Michigan and met his wife, me, Carol, after, after a postdoc in Texas. Then time living and working in Arizona and Maryland, he returned to California in 1996 and has lived in California ever since. He and Carol moved to Los Osos in April 2020. We have traveled extensively, believing that by experiencing other cultures and communities, we become better citizens of the world. Tonight, Alex will take you to a part of the world that few Americans visit, even though the locals speak English, sort of, and live a very comfortable life, definitely. Even less is known is that this area is a biodiversity hotspot for orchids. I'm talking about Southwestern Australia, 10,000 miles and 9 hours of time difference away. Take it away, Alex.
Okay, thank you. Welcome, everybody. I'm glad to be here and I'm excited to talk about a pretty amazing part of the world that a lot of people have never visited. So I will get started here and share my slides. Um, let's see here. Whoops. Um, that's a good start. Now let's get this show on the road. There we go. Okay, I think we've got it there. And okay, so this trip is based, or this talk is based on 2 trips to southwestern Australia, one in 2011 and one in 2019. And each trip had an effective period of about 2 weeks to enjoy the place. And I'm going to talk about the biology, a little bit about the geology, some of the wildlife, definitely focusing on the plants of southwestern Australia. The jumping off point for exploring southwestern Australia is the city of Perth at about 32 degrees south latitude. It is eerily similar to San Diego, like an alternate version of San Diego, about the same population size at the same latitude with very much the same climate. There are some differences though. Here's Carol, and even the downtown looks a little bit like San Diego. Now, the area we're talking about here is this little corner here of Australia's Western Australia, from Perth about 200 miles as the crow flies south to Albany, and then Denmark, which is where a lot of the pictures were taken, and then the Stirling Range, which we'll talk about as well. The big difference between San Diego and Perth is that Perth is the most isolated state capital in the world. The distance here to Adelaide would be like if the next city of any size, instead of being LA or Oakland or Sacramento, was Dallas Fort Worth. That's about the same distance to fly here as it is to Perth. There are a lot of similarities between the Central Coast and let's see if that makes a difference there. Nope. Okay. There are a lot of different similarities between California's Central Coast and Southwestern Australia. Both have climates with a cool, rainy winter and a warm, dry summer. They have an awesome coastline and beautiful beaches. In both places, wildfire is a natural force and a threat to human communities. The plant communities are diverse, from open woodland and shrubland to dense tall forests. Like the Central Coast, Southwest Australia has many vineyards, wineries, artists, and art galleries. It also has a very high cost of living and inflated real estate markets. And finally, last but not least, neither place has crocodiles. Here's another view of Perth from a large metropolitan park, Kings Park in Perth. It's a beautiful, pleasant city in its splendid isolation. Another view showing the bay there and the low mountain range, what passes for mountains in western and southwestern Australia. Here's a landmark, a traffic landmark in downtown Perth. And in similarities, as I mentioned, there's a lot of upper class prosperity. Here you can see multi-million-dollar houses, McMansions, on the side of a hill. It looks a little bit like Cayucos or the Mesa in Santa Barbara or Upper Newport Bay in Orange County. Big houses, big ostentatious houses. The downtowns have their charm, a different style of architecture, which is uniquely Australian, with cafes and shops for tourists and for locals. Very livable communities. As you know, Australia was largely populated with convicts who were sent there from Great Britain in the 1800s. And just about every major city in Australia has a prison. Many of them have been turned into tourist visitation sites. I don't know if I call them an attraction or not. And this is Fremantle Prison, which is just outside of Perth. Albany is a town of about 15,000 or so it's pretty close to Los Osos sized, and it's on the Southern Ocean. The Southern Ocean, of course, separates Australia from Antarctica, several thousand miles further away. And in a community like Albany or Denmark here, which is even smaller, they have a very comfortable lifestyle. Cafes, lots of good restaurants, beautiful beaches, like I said. And I'm not sure what this poor dog here did to get sent out and away. A poor dog. In addition, beach recreation here shows it could be somewhere off our shore. The water is cold, but people are still out there enjoying it for surfing, swimming, etc. As far as wind power and green energy goes, there's been more initiatives at the state and local level than at the federal Australian level. The federal Australian government is almost as backward as the US one, but the local citizenry is more progressive. And this picture was taken in 2011, and already at that point, Albany was largely powered by wind, onshore wind. And they were plugged in to the concerns about climate change, and they participated in the global climate strike. This was back in September 20th of 2019. Here you see the coast. Looks like it could be MDO, but this is not the coast down north of a nuclear power plant. This is the coast of the Southern Ocean and just outside of Albany. And that Southern Ocean generates powerful swells from the storms in the roaring 40s between Australia and Antarctica, and it comes on shore just like it does here in the winter and spring as big surf. Now let's talk about some of the habitats that we can see in the vicinity. Coastal heathlands are the Australian analog to coastal sage scrub. Again, the plants are entirely different, but this is a very biodiverse plant community. It is considered one of the world's great temperate zone biodiversity hotspots. Large forests with large trees. There aren't any redwoods, but there are eucalyptus species, a couple of them which get to very, very large size, and they form tall tree closed canopy forests. Here's one view of this. So instead of having redwoods around Santa Cruz or Big Sur, you've got giant eucalyptus, and they do reach the size of redwoods. This one here has a diameter which is at least a dozen feet, more than a dozen feet across. The big difference between redwoods and eucalyptus is eucalyptus heartwood is of very inferior quality. And over long periods of time, this tree's center has completely rotted out as a result of fire and fungus and insects. But it's still in a massive, the outer parts of living secondary xylem and phloem and bark and cambium still support a tree, amazingly. And this is what the forest would look like. So instead of having redwood forests near Santa Cruz, you have these eucalyptus forests, and a lot of the land is protected in national parks. Canopy, 40 to 60 meters tall. Some of the emergent trees, I'm sure, get up to 70 meters high. Big trees in such places. For hikers, like New Zealand, Australia has tracks, which are long trails. This trail here is several hundred miles long. The Bibbulmun track, it goes all along from the southern tip of Southwest Australia on up towards the northwest. And it provides long distance hiking opportunities for those who want to partake. The forests get rainfall. Rainfall varies between, sort of like California, between 25 inches equivalent to up to 70 or 75 inches of the forest. And in the wetter places where there's forest, it supports pretty fungi like these cups and the asparagate fungi growing on the side of a fallen log. Here's another view showing us in another fire-hollowed eucalyptus tree trunk. As far as other geology, it is fairly flat and has more in common with Appalachia, but there are mountain ranges, isolated mountain ranges surrounded by basin country. This is the Sterling Range in particular. We'll be saying more about it in a few minutes. And a beautiful view. Closer up, you can see the Sterling Range. It gets up to about a height of about 1,000 meters, a little over 3,000 feet. And on cold winter storms, it will get snow. In fact, there's even what they call a skiing area up at the top of that, although that was kind of dubious if you count it against modern standards. The Sterling Range is protected in a national park, which supports several unique ecosystems and plant communities that call this place home. One of them is the montane heathland, which is on coarse, rocky soils, distinct from the coastal heathland. And here I am attempting to summit one of these that is about 3,000 feet with about close to 2,000 feet of elevation gain from the basin below. Perth, let's talk a little bit more about Perth. Its iconic bird is the black swan, of all things, and you can go there and you'll find them. And this is going to introduce a section on wildlife, I think, is coming, starting with some birds. Okay, note to Americans and Doug, this bird is pronounced emu, not emu. Okay, but it is one of Australia's two large flightless rat-tied birds in the ostrich family. The other one is the cassowary. And then you have the colorful birds from the parrot family. Picnic table visitors, literally. Quite a diversity. And some of them are absolutely stunning. To have this show up at your picnic table, how could you deny these guys some scraps? Well, I think we did, but they're still beautiful. They have a white pelican species. It's different from ours, but it's about the same size. The bill is a little less orange, perhaps. And spoonbills, which we don't have in California, although they are in the southeastern United States. This is a different species of spoonbill that's found there. And finally, in the family with crows and ravens, you have the Australian magpie. They also have an Australian crow. And kookaburra sits in the old gum tree. Okay, laugh, kookaburra, laugh. They're the birds which are used for the soundtrack, actually, for the Tarzan movies. That I'm not going to try imitating that sound, but it's not from Africa. It's a kookaburra from Australia. And finally, can't have an Australian slideshow without a picture of some kangaroos here in Denmark. They're quite common and easy to see in the southern half of the country. They get a little rarer as you go norther into the tropics. And then here we have a bobtail skink. This is a unique group of lizards, one of several that are found in Australia. It has incredible reptilian biodiversity as well. Here's a black skink with one of the first plants. This is my cue that we're going to transition to plants. Grevillea. Black skink, this is about an 18-inch long lizard for scale. And here, do we have animals here? Yeah, we have a honeybee. Honeybees on Grevillea. And Grevillea is also planted widely in coastal California, but it's an Australian native. And Banksias are also used in California drought-tolerant landscaping. They, of course, are also Australian natives. Another species of Banksia. And yet another with foliage which is very striking and unusual. And one last picture of Banksia flowers. These are families of plants which are not represented in California, at least not naturally. Here we have the kangaroo paw. It's also used in California landscaping, but it is, of course, an Australian native. And we have the gum trees. The eucalypts typically have these staminate flowers, as they're called, where the male parts are prominent. The petals have been greatly reduced in these flowers, and they can be beautiful like this one when they're in bloom. And of course, Australia is known for acacias, the wattle trees as they call them. And in this case here, there are, I think, 700 species of acacia in Australia. Just an amazing diversity. Some of them have flowers that are elliptical like this. Again, these are flowers where the petals have been totally reduced. Here is another species of wattle, and this leads me to the discussion of the Australian sports team colors. When they compete in the Olympics, they wear uniforms of yellow and green, which are not present on the national flag of Australia. You might say, how did that get started? It got started because the color of wattle flowers against the green foliage was an iconic imagery for Australian settlers and for indigenous Aboriginal people. And so this yellow-green combination is what ended up on the sports uniforms rather than a red, blue, and white combination. And here's a bottle brush, again, commonly used in plantings in California. And a type of bachelor button, again, an Australian native. Two flowers of the pea family, which brighten the landscape and give it vibrant flower colors in the spring. Here's the second one, and they're just beautiful. They brighten the day and make it beautiful. And then there are other Australian natives. This is one that's in the iris family, monocot. Another similar plant showing the flower parts here. And here's a flower cluster. It's different from anything you'd find in the US because there is a bulldog ant here that is waiting to in ambush for butterflies or bees or flies to come to the flowers. And bull ants or bulldog ants have a powerful, painful sting, and they're formidable predators on other insects. And here we have everlastings, a common member of the daisy group, composite, common in southwestern Australia. And actually, there is an orchid in this picture. You may not be able to see it, but it is right here, again against the background of the white and pink everlastings. Now we come to the orchids, because this area is a biodiversity hotspot for not just the plants in general and animals, but for orchids. But the orchids that are here are different in many ways from what we're familiar with, certainly very different from what you find or buy wrapped in plastic at Trader Joe. They live on sandy soils, in coastal and inland habitats, and a variety of different habitats, most often though in open woodlands or heathlands where there's lots of abundant sunlight. They're not epiphytes like the orchids you see grown around here. They are rooted in the soil, and they come from small tubers underground, sort of a little bit like an iris, and they're terrestrial perennial plants. That means they regenerate each year. The plant growth begins after the autumn rains arrive, and that's usually in August or September, or earlier, even as early as June. And then the plants grow through the winter, and they bloom in the spring, which is August to November. And then as summer approaches and things die back, the plant stems and the leaves die off during the warmer, hot, dry season. Some species have well-known fire-associated ecologies, and the flowers typically last for many days or even weeks. Now, before we go further with this, from current slide. Okay, there, I'm back in business. Okay, let's talk about coevolution. Coevolution is an important concept. It involves two species that are ecologically interacting, and they evolve in response to selection imposed by the other species. When one talks about symbiosis or mutualisms as a type of symbiosis, all symbioses are a product of coevolution. And orchids are a special case of this, because these Australian orchids co-evolved with their specific pollinators, unique species of bees, but not honeybees, because there were no honeybees in ancestral Australia, wasps, ants, or other insects. So they have particular pollinators which they've evolved relationships with. In addition, Australian orchids co-evolved with their soil microbiome, that is, fungi and bacteria that are uniquely present in the Australian soil, to help absorb nutrients and to help the seedlings germinate. Let's go over the parts of an orchid flower before we start showing pictures of them. The outer parts of the bud that make it up are called the sepals. So when you look at an orchid bud that hasn't popped open, you're seeing the three sepals that hold it together at the back. And when the flower pops open, these three parts separate first, and then are exposed the three petals, 1, 2, and 3. In orchids, one of the petals is modified into a special unique structure called a labellum or lip. And all of these parts are colorful, designed to attract the attention of pollinator insects. The reproductive parts of the flower are located on this column here. The column here contains the ovaries, and it contains the pollinia, which are the male pollen producing structures. And they're tucked in here, often deep within this column. And the ovary itself is often in the stem behind the parts of the orchid flower. That's the part which would actually swell if seeds are to be produced. First orchid we'll talk about here may represent something like what the ancestral orchids looked like 60 or 70 million years ago when the lineage first evolved. And in this case here, the column has evolved and it has that distinctive structure which marks the orchid family. But the petals and the sepals are not differentiated very well. Here are the three sepals that form the outer part of the bud. And when it pops open, you get these three petals. This one is the lip, but it looks identical to the other two petals. So it's undifferentiated. Lemon-scented sun orchid. At the other extreme, you have flowers which are highly differentiated. The donkey orchids, for example. In this case here, the flowers are highly modified, so that this is the labellum here, and you can see the column is sort of tucked in here, but otherwise it's got a very unique floral morphology. Places to find orchids in southwestern Australia: pasture land, meadowland, national parks. This is Mount Lindesay National Park. We went in there on our own, and I knew I wasn't anywhere in the United States where without a guide I could find close to a dozen different species of blooming orchids on one day. The habitats: Jarrah woodland is an open woodland. This is an area which obviously looks like it had been fire stressed at some point in the past. There's some burn scars here. These plants here are what are called grass trees. They're a unique plant of Australia. The closest place I can think of that has them is Lotus Land in Santa Barbara. You can see grass trees. It's a uniquely Australian plant with a trunk. And then orchids thrive in a mosaic of habitats: pasture lands, heathlands in this case here, and then open woodlands where there's still an abundant light for them to grow. Let's start in on some orchids. These here, leek orchids, come closest to what an American orchid aficionado who goes out in the woods of the North Country or back east and looks in a boggy area might find something that looks like this, where you have many, many different small flowers mounted around a central stem. And that's what we're looking at here with these leek orchids. In this case, this part here is the labellum. The column is tucked in there. On this one here, if I can get my mouse to work, it is not going to work. There you can see the labellum as well. Silky blue orchid, pretty. I had to include this one here because this orchid has a smiley face on the labellum. And another orchid didn't exactly determine the species or didn't label it. Purple enamel orchid, Elanthera brunonis, is a common orchid in the springtime down there, and it is small but brightly colored and has this enamel-like luster to it. Here's one of the donkey orchids. In this case, this is the pansy orchid, and it's in the same group though. We found this one along the side of the trail, and it was quite a treat to find this orchid in bloom. Of course, one pansy orchid picture deserves another one. They're so pretty. And so here we are. We can see this as well. Little pink fan orchid is small. It's less than an inch across here. And the little pink fan orchid is a woodland species usually found in the forests. Leaping spider orchid. How it got its name, I'm not sure, except that all of these orchids that we'll focus on in the genus Caladinia are generally classified as spider orchids. And here's a Caladinia macrostylus, the leaping spider orchid. And it's about a, a little over about 2 inches across. As I mentioned, the terrain of Southwest Australia has low isolated mountain ranges separated by basin country. Often that is ranchland or farmland or open woodland. And the orchid biodiversity here is absolutely stunning. This looks like it could be the bottomland in Atascadero or Paso, along the river, Salinas River or something. But it's not. It's Mount Trio Caravan Park, which is on a ranch, surrounded by farmland, a place where campers go. And it doesn't look very, prepossessing or anything like that. But it is the center of awesome orchid biodiversity. We spent 90 minutes here walking around, covering a distance of about 1.5 miles, looking at orchids. And all the pictures I'm going to show going forward from here were taken during those 90 minutes walking around. And all of these plants were out in nature, rooted in the ground, not in a greenhouse or a botanical garden. It's worth noting that Mount Trio Caravan Park is surrounded by fields of canola, which is also grown widely in coastal California. So these orchid populations are somewhat isolated from each other, and there certainly is some concern for their future viability. Again, another view of Mount Trio. Again, eucalyptus woodland, and the orchids are down here. You'd have to get down on your hands and knees to see most of them here. This is biodiversity. This is what biodiversity looks like. It's not a listing of craft brews on tap. It's a listing of orchids currently in bloom in one location. We came in, we took this picture, and then we set out to find what we could find. We did have a guide who helped us out finding things, but it was all plants which nature had planted. So let's get started. Pansy orchids are pretty. So we include another one of these in this slideshow. Do I have to tell you why this one's called the rabbit orchid? I didn't think so. Rattlebeak's orchid. Now, I'm not sure why this one got that name. Maybe there was a famous botanist named Rattlebeaks. I don't know. We're going to focus on one genus from here on out, the genus Caladinia, because this genus shows a major evolutionary concept, adaptive radiation, which is defined here. Repeated, fairly rapid evolutionary divergence of members in a single evolutionary lineage, a phylogenetic lineage, to produce a large variety of different species, genera, families, etc. And all of you have heard of adaptive radiation or are aware of some of the examples of it. Darwin's finches on the Galapagos Island gave him the idea for adaptive radiation. There are a couple hundred species of fruit flies on the Hawaiian Islands, again, a product of rapid adaptive radiation over the course of just a few million years. Cichlid fish are famous in East African valley lakes. There may be over 100 species in a lake, and again, they're related, but they were produced by a process of adaptive radiation. Ants in the genera Phydolia or Camponotus. These are genera which have hundreds or even 1,000 or more species in them, and they're very successful, and adaptive radiation is the process that has produced all those species. Orchids in the genus Dendrobium or Bulbophyllum are another example of fantastically successful genera that have produced hundreds of species in a fairly short period of time. And again, on the Hawaiian Islands, the silver sword family, different plants which exist as a vine, a shrub, a tree, and all had a single origin just a few million years ago. Let's start with something that may be fairly close to the ancestral form for the Caladinia genus and its adaptive radiation, the clade. The cow's lip orchid, Caladinia flava. Flava means yellow, hence the color. And the two features that are diagnostic for Caladinia. This is the lobellum, and our lateral lobes or processes like a comb that extend along the lateral margin of the lobellum, and structures called calli, which are these structures here, which often form tufts or ridges that are along the central part of the lobellum. These two features together, they're diagnostic for this genus Caladinia. And Caladinia has over 100 species in Southwest Australia alone. Pretty amazing. And we saw a lot of them in bloom just on a single day, in a single general area. Here's the pink fairy orchid, Caladinia latifolia. And again, you can see the lateral processes on the lobellum. And you can see here the calli, these little yellow structures here in the middle. The pink fairy orchid. Beautiful. Got to have another picture, even though there's a beetle here photobombing the picture and something else blooming in the background. But again, you can see these are the calli on this side here, and you can see these lateral processes. Pink fairy orchid. Pink candy orchid, Caladinia hirta. And here you can see the lateral processes sort of spike-like or comb-like. And then the calli form these rows of these colored dots down the middle. And this is sort of like a landing marking on the end of a runway to cue the bees or wasps in, like land here and taxi here, to get your reward. The white fairy orchid. Okay, very similar. Again, lateral lobe-like processes and the calli. Heberle's spider orchid, Caladinia heberliana. When you see something like this in the woods, you know you're not in Kansas anymore, or you're not in California anymore. This is a spectacular flower, which is about 3 inches across. You don't need a microscope to see it. Let's get in closer and take a look at this beauty here. Here, the lateral processes are produced into these spikes, and you can see the rows of calli marching down the center of the lobellum. Heberle's spider orchid, stunning, a beautiful flower. The king spider orchid, Caladinia pectinata, different color, but again the same theme of these spikes along the lateral margins and 4 rows of calli in the middle. And this is the column here, this structure here. So the bee or wasp would come in here and go down in there to carry out its pollination function. Joseph's spider orchid, Caladinia polychroma, probably got its name from Joseph's, the story of Joseph and his coat of many colors. Polychroma means many colors. So I think that's the connection. Pretty good guess. And here it is closer up, showing, in this case, the lateral margin is a little smoother, but you can still see there are calli located here. Here's the column. And it's also worth noting that the leaves of these plants are very unassuming. It looks like a slightly hairy grass blade. Some of the plants have very large flowers indeed. Caladinia vulgaris, this is against a gardener's hat, and you can see that this plant is probably 7 or 8 inches. This flower is probably 7 or 8 inches. In fact, the flower here is bigger than the plant down here. If you look at that, you can see that difference. The stark white spider orchid is another giant orchid that you can see. And again, you can see the lateral spikes here on the labellum or lip, and then there are 4 faint rows of dots here. Those are the calli that give this plant its appearance. Another view closer up because it deserves a closer viewing. A beautiful flower, Caladinia longicauda, which means long-tailed, referring to these long flower, in this case here. These are long petals that this plant has. We get to more and more bizarre shapes and more bizarre habits. The butterfly orchid, Caladinia lobata. Here, this is the labellum. It's upside down. It opens with the flower facing upside down. Again, you can see the spikes along the lateral margin of the labellum. The calli sort of hidden in this view here. This is the column, and this would conceal the pollinia in here, and the ovary would be down in this stem here, and an insect would come in here. But what happens with these, I'll tell you in a minute. It's a little bit weirder than that. And the fringed mantis orchid, Calodenia falcata, is another one in this group here. Here again, it opens with the labellum pointed upwards. You can see the spikes here on the lateral margin of the labellum. This is the column. The pollinia are tucked in here. And again, the insect would come in over here and tuck itself down in here. The last orchid I'm going to show you is the dragon orchid, Calodenia barbarossa. And what that term means is it's the rust-colored bearded orchid. And this is the beard, and it is sort of rust-colored here. And this one here is kind of rare, and it has a unique habit. Let's talk about how these guys get pollinated. Pseudocopulation. A few of you already know about this, but many of you don't. So let's define it. It's a parasitic pollination strategy where a flower mimics the female of a species of bee, wasp, ant, or other insect. She may look like the female, she may smell like the female, or both. And this attracts males of the same species that are hoping to get lucky, so to speak, and they attempt to couple and mate with the bogus female, and as they press close, they extract or deposit pollinia on the flower. The male, he gets nothing out of this. Well, I don't think he does. The plant gets pollinated, gets its pollen moved to another plant, because of course the male doesn't learn anything, and he's going to try the same thing repeatedly on different flowers and will transfer the pollen as he does so. So how does this work here? Well, this plant produces fragrance. It has enough of a shape to look like the female wasp, in this case, a wingless female wasp. And the male will come in and he'll land here, and he will attempt to press and squeeze. And as he squeezes this flower in his passionate embrace, the pollinia will be deposited onto him, and he will then carry them to another flower. And in this case, the poor chump pollinator is a thinid wasp. Alrighty, how did we do in this illustration? Well, here's our list again, and we put X's by everything we saw. And this was better than Pokemon. We found most of the flowers of most of these species in the field, walking 1.5 miles in one area on 90 minutes on an unremarkable spring day, okay, in September. And look at all of these that we found here. Quite an impressive biodiversity. So to wrap it up, what can I say about this? How can so many different yet related orchid species thrive in one place at one time? And they're all in bloom. How do they avoid getting mixed up? And how do their pollinators avoid getting mixed up? And the fact of the matter is, orchids hybridize easily. Nearly all the orchids in commercial cultivation that you've seen or bought or have in your home are hybrids that have been produced artificially. It's easy to hybridize orchids. So how do they stay separate? And in fact, some natural hybridization has occurred between Calodenia species in Australia, between the cowslip orchid and some other species, for example. It's not unknown. But the key has to be reproductive isolation, which was first deduced by Darwin back in the 1800s, and it describes natural barriers to hybridization, forces that act to maintain distinct species, separate species, and thereby biodiversity. They don't all hybridize to produce one single descendant species. And part of this is that each orchid species has a unique relationship with its pollinator insect species. And this is called pollinator fidelity, and it's common with orchids that they've co-evolved with some insect. And this is a key to making sure the pollen goes to the right address when it is picked up by a particular specialized pollinator. It is a danger, though, because if that pollinator species goes extinct, that orchid may well follow it into extinction. So there's a real worry, a double-edged sword in relying on a particular pollinator. And yet, when you look at the soil, all these orchids are living in what looks like undifferentiated sand to us, like a big sandbox with lots of other things living there too. How do they reduce their competition? One has to rely on the concepts of niche partitioning and specialization. These orchids must do somehow slightly different things in slightly different ways to reduce competition among all these species so that this one community can support all of these blooming orchids. And it's worth keeping in mind that this is one day. If you were to come a month and a half later, you would probably see a whole different set of species in bloom. And if you'd come a month and a half earlier, you might have seen, again, a set of different species. So this is showing you just biodiversity at one time. But it is certainly an awesome demonstration in nature that biodiversity is a real thing, and it's something that I hope all of you will get the chance to experience, whether in Australia or somewhere here in the USA. And that brings me to my conclusion here, to my end of my talk. The beauties of Australia and these sunset, and it's a beautiful place to visit. I encourage you to go there if you get the chance, and plan on going for several weeks to see it there. And let me see, there we go.